Soviet Sputnik, the first man-made satellite as it passed over New York earlier today.
On October 4, 1957, the Soviet Union successfully launched the world's first artificial Earth satellite.
There are hundreds of problems that we'd like to solve with these satellites.
Stunning the United States at the height of the Cold War, the Soviet Union unveiled Sputnik 1 to orbit the Earth in a feat no one imagined they could pull. This unassuming metal sphere managed to jolt the world into a new era, quietly unraveling secrets that both terrified and enlightened us. After just 22 days of exploration, a terrifying discovery has been made. That, ever since, has not been revealed until now. This satellite has dropped revelations that would reshape our understanding of the universe. What are these discoveries made by Sputnik 1? How has it affected our connection with our world? Join us as we unravel the details of this disturbing discovery. History of the Sputnik launch. On October 4, 1957, the Soviet Union launched Sputnik 1 into low Earth orbit. Well, it wasn't much to look at. It was just a metal ball measuring 22 inches or about 56 centimeters in diameter, adorned with 4 antennas. Yet, despite its modest appearance, its impact on human history was profound. The concept of a satellite had been initially proposed in 1954 by Mikhail Tikhonravov, a Soviet engineer, while his former boss, Sergei Korolyov, focused on developing the world's first intercontinental ballistic missile, ICBM, the R-7. Tikhonravov envisioned that if a missile could traverse the planet carrying a nuclear warhead, it could also launch a satellite into orbit. Recognizing the potential, Korolyov presented the idea to Defense Minister Dmitry Ustinov. By January 30, 1956, a government resolution called for the production of an unoriented satellite, dubbed Object D, weighing between 1,000 and 1,400 kilograms and equipped with scientific research equipment. However, the Soviets weren't the only ones eyeing space. In 1955, U.S. President Dwight D. Eisenhower pledged to launch a satellite during the International Geophysical Year from July 1957 to December 1958. As the Soviets faced challenges with the R-7 rocket's thrust, they opted for a scaled-down version, the Prostейший Sputnik, or simple satellite, weighing just 83 kilos. It was a metal sphere with a heat shield housing transmitters, batteries, and a ventilation fan. On October 4, 1957, Sputnik embarked on its journey from the Baikonur Cosmodrome in the Kazakh Republic. It reached an elliptical orbit with a maximum height of 900 kilometers, circling the Earth every 96.2 minutes at a speed of 29,000 kilometers per hour, transmitting on 2 radio frequencies, 20.005 megahertz and 40.002 megahertz. Impact of the Sputnik launch on the United States. Indeed, Sputnik 1 made quite a mark before the world even knew it existed. It had silently passed over the United States twice, undetected, until the Soviet news agency TASS spilled the beans. With the right radio gear, anyone could tune in to Sputnik's beeps. While the satellite's sole purpose was emitting these beeps, which is how it returns data to the ground station, scientists seized the opportunity to measure signal distortion. This led to groundbreaking insights into the density of the upper atmosphere and early revelations about Earth's ionosphere. Beyond being a beeping sphere in the sky, Sputnik's impact was immediate and global, famously termed the Sputnik moment. In the United States, the reaction was nothing short of hysterical. Americans, perhaps complacent in their belief of their technological superiority, were suddenly jolted awake. The notion that they were falling behind the Soviet Union in the technological race, especially in space, sent shockwaves. The event triggered what some would later call a Sputnik moment, a realization that their Cold War rivals were more than capable. In response to this perceived threat, Anxiety ran high in the United States. People feared that the Soviets, with their newfound space prowess, could potentially deploy superior weaponry. President Eisenhower attempted to calm the nation, expressing minimal concern about the satellite itself, but acknowledging three undeniable truths. The USSR had space dominance, U.S. prestige was on the line, and the Soviets could achieve military superiority. As American scientists grappled with the realization that Sputnik, though smaller than their planned Object D, was over 8 times more massive, a publicized failure in December 1957 of America's first satellite attempt fueled the perception of the U.S. lagging behind the Soviets. Boris Chertok noted that the Soviets held a 3-year lead until the U.S. space program surged ahead with Gemini and Apollo, culminating in Alexei Leonov's historic spacewalk in 1965. Eisenhower called upon his fellow Americans to respond with resourcefulness and vigor. His administration took substantial steps, dissolving the National Advisory Committee for Aeronautics and birthing NASA on October 1, 1958, with a then-equivalent budget of $730 million annually, a far cry from the $18 billion today. By 1965, at its peak, NASA commanded a budget equivalent to $44 billion, representing over 4% of the U.S. federal budget. To address concerns about Soviet educational superiority, the U.S. government passed the National Defense Education Act, encouraging young minds to delve into physics and mathematics. Meanwhile, Sputnik continued its beeping until its batteries expired 22 days post-launch, orbiting until January 4, 1958, before burning up on re-entry after completing 1,440 orbits and covering a staggering 70 million kilometers. The terrifying and fascinating discoveries made by Sputnik 1. Before Sputnik shut down and returned to Earth, it had aided scientists in making some discoveries. As mentioned, the satellite emitted beeps, and scientists jumped at the chance to gather more than just auditory data. They leveraged the satellite's signal emissions to delve into the intricacies of our atmosphere. This seemingly simple act of listening to beeps unveiled a treasure trove of information about the density of the upper atmosphere. Sputnik didn't stop at revealing atmospheric secrets, though. It also gave us a sneak peek into the Earth's ionosphere. This is the layer of the atmosphere brimming with charged particles, and Sputnik, unwittingly or not, became our guide through this celestial maze. The distortions in its signals unveiled a whole new realm of knowledge about the ionosphere, a part of our planet's atmospheric makeup that was until then a bit of a mystery. Now, the beauty of all this lies in the fact that these weren't just isolated discoveries. They opened up new doors of exploration and understanding. The data gleaned from Sputnik's beeps became foundational for further research. It paved the way for advancements in atmospheric science, leading to a deeper comprehension of how our planet functions on a larger scale. It happened like a scientific domino effect. Sputnik's beeps sparked curiosity. Curiosity led to analysis. Analysis resulted in discoveries. And these discoveries, in turn, fueled more questions and exploration. However, the newfound knowledge about the upper atmosphere and the ionosphere was a double-edged sword. On one hand, it was remarkable, offering a peek into the unseen realms above. But, and there's always a but in scientific exploration, it also brought about a realization of the complexities and potential challenges lurking in our atmospheric makeup. Scientists realized just how delicate and interconnected the atmospheric systems are. The worry that crept in stemmed from the awareness of how sensitive these atmospheric layers are to natural or human-induced changes. Take the ionosphere, for instance. As scientists peeled back the layers of its mysteries, they began to fathom its vulnerability to external influences. Suddenly, questions emerged about how human activities might impact this charged realm above us. It was a sobering realization that what happens on Earth's surface doesn't just stay there. It reverberates through the layers above. potentially affecting the delicate balance of our atmospheric ballet. This, of course, caused significant concern among scientists. They were terrified not about the discoveries themselves, but about their implications. It was a sober acknowledgement that our actions on Earth could have ripple effects, quite literally, reaching into the far reaches of our atmosphere. And today, we can see they indeed are. How the world responded to Sputnik 1. Sputnik, the Soviet satellite, not only aided our understanding of our environment, it also kick-started the space race and ushered in a new chapter in the Cold War. While it introduced new worries, it also ignited a sense of wonder and exploration. This mix of wonder, politics, and propaganda prompted President John F. Kennedy to declare the ambitious "We Choose to Go to the Moon" speech on September 12, 1962. Just 7 years later, Neil Armstrong set foot on the moon on July 20, 1969. Many experts credit the Sputnik shock for expediting this lunar milestone. Without that pivotal moment, reaching the moon might have taken much longer. While the Cold War raged on for another 34 years, marked by the accumulation of ICBMs and the ominous Star Wars space weapons program, the Sputnik moment and its global response spurred technological advancements. It served as a catalyst, inspiring a generation of engineers and scientists and influencing space exploration, international communications, and the comprehensive analysis of our planet's history, present, and future. The U.S. even set its sights on creating its own starry emissary. Nova was born out of this space-age competition, a nod to the monumental moment when Sputnik pierced the cosmic veil. However, Nova wasn't just a mere mimic. It had its unique flair. It was designed to be a scientific heavyweight, carrying experiments to unravel the mysteries of space. The satellite was crafted with precision, a delicate dance of engineering marvels to ensure it could withstand the harsh realities of space. In 1960, Nova made its grand entrance into the cosmic stage. It soared into space as a response to Sputnik and a testament to human ingenuity. While Sputnik's beeps were a hello, Nova's mission was a conversation, delving into the scientific intricacies of our celestial neighborhood. The satellite's cosmic journey lasted about a decade, gracefully orbiting our planet and beaming back valuable data. It wasn't a mere replica of Sputnik. It was an American cosmic envoy, contributing its own verses to the celestial symphony. One of Nova's standout achievements was in the realm of cosmic rays. Cosmic rays are energetic particles zooming through space, and Nova had a front-row seat to study them. It became the scientist's detective, collecting data on the origins and behavior of these elusive particles. This satellite also delved into the mysteries of the Earth's magnetic field. It observed the intricate dance between the solar wind and our planet's magnetic shield. If that's a new term to you, solar winds are those charged particles flowing from the sun. Nova had a ringside view of this celestial breeze, studying its interactions with the Earth's magnetosphere. It helped us understand the dynamic relationship between our planet and the sun. But the American satellite didn't stop there. It extended its scientific tentacles to study the Earth's upper atmosphere. It provided insights into the atmospheric dynamics that influence our planet's climate. Its observations improved our understanding of how Earth interacts with the cosmic weather patterns swirling around it. Nova played a pivotal role in our comprehension of the Van Allen radiation belts as well. These are regions around Earth filled with charged particles, and Nova became our space explorer, navigating these celestial neighborhoods and unraveling the mysteries of these radiation belts. In essence, Nova wasn't just a satellite, but a scientific beacon illuminating the cosmic shadows. It contributed to our knowledge of cosmic rays, Earth's magnetic field, solar wind interactions, upper atmospheric dynamics, and the enigmatic radiation belts. Looking at the U.S. space program's recent goals, they aim to send humans to visit an asteroid by 2025 and achieve the monumental task of putting a human on Mars during the 2030s. Whether these objectives materialize remains to be seen. Yet they echo the impact of those beeps from a little metal sphere 60 years ago, a testament to the enduring influence of Sputnik's legacy on our aspirations for space exploration. What do you make of the incredible Sputnik innovation and its impact on our understanding of our environment? Let's hear from you in the comments section. Also, make sure to like this video if you enjoyed it. Subscribe to the channel for more, and we'll see you soon.